The 737 has three hydraulic systems. They are System A, System B, and the standby system. The hydraulic systems have reservoirs in the main wheel well. System A and System B operate independently. A hydraulic servicing line connects System B and the standby system. The bleed air system supplies air pressure to Systems A and B reservoirs to make sure there is a positive flow of fluid. System B supplies pressure for the standby system. The number 1 engine-driven hydraulic pump and an AC electric motor-driven pump supply the pressure for System A. Under normal conditions, the number 2 generator powers the electric motor-driven pump for System A. The number 2 engine-driven hydraulic pump and an AC electric motor-driven pump supply the pressure for System B. Under normal conditions, the number 1 generator powers the electric motor-driven pump for System B. One AC electric motor-driven pump supplies the pressure for the standby system. System A supplies hydraulic power to these units, and System B supplies hydraulic power to these units. If Systems A and B do not operate, the standby system is available to supply hydraulic pressure to the rudder, the leading edge devices, and the thrust reversers. The Power Transfer Unit, or PTU, supplies additional volume of hydraulic pressure to operate the auto slats and the leading edge flaps and slats at the normal rate when the pressure of the System B engine-driven pump drops below limits. The PTU control valve opens when the output pressure from the System B engine-driven pump drops below limits. The airplane is in flight, and the flaps are less than 15 but not up. When the PTU control valve opens, System A supplies hydraulic pressure to operate the PTU. The PTU uses System B fluid to supply pressure for the auto slat system and the leading edge flaps and slats. If the number 1 engine fails, the landing gear transfer unit supplies hydraulic fluid volume from System B to raise the landing gear. In System A and System B, the engine-driven pumps supply a larger volume of fluid than the electric motor-driven pumps. If the left engine fails, System A does not supply sufficient hydraulic volume to quickly retract the landing gear. The electric motor-driven pump continues to operate as usual, but the total hydraulic volume of System A is less. The landing gear transfer unit operates when the number 1 engine N2 is less than idle. The landing gear lever is in the up position, and one of the main gear is not in the fully up position. The landing gear transfer unit supplies System B hydraulic fluid volume to retract the gear. The lower display unit shows the pressure of System A and System B. There is no pressure indication for the standby system. The normal pressure for the three systems is 3000 psi. The lower display unit also shows the quantity of System A and System B hydraulic fluid in percent of full. For example, 90 shows that the reservoir is 90% full. If the quantity is low and the airplane is on the ground, the system shows the letters RF, or refill, adjacent to the quantity indications. The hydraulic brake pressure indicator shows the hydraulic brake pressure. The normal brake pressure is 3,000 psi. The controls for the hydraulic systems are on the forward overhead panel. System A and System B controls are on the hydraulic control panel. And the standby system controls are on the flight control panel.